All right, thank you everyone, and welcome to the next session called Managing Operations with Temporal in OSM. So how did this start? Well, first there was OSM. OSM was able to deploy to OpenStack. I mean, there's a lot more history to it than that, but as far as clouds go, the first significant one is OpenStack. And we added additional things like some public clouds. We added support for Kubernetes. Microsoft Azure support was added, GCP. And now we know that Juju right now is being used, and it can as kind of the execution engine. It's a bit of an execution engine lifecycle manager. It's capable of managing the lifecycle of some things, but we're not really employing it for that right now. What we do in OSM is we would launch like a VM or so, register that with Juju, and then allow Juju to proceed if we wanted to do things like what we call native charms. Which got me to thinking, I wonder, what happens now if we take Juju and we make it a target for deploying software? So that's what we started calling this platform as a service, or our Juju PaaS plugin for short. So, we started talking internally, throwing some ideas around about a new platform. And we could look at some of the ways we could organize code in OSM to prototype some ways of paying down a little bit of our technical debt, as well as exploring this concept of a PaaS plugin. Enter Temporal. Or as their tagline in their introductory slide deck says, why durable execution changes everything. OSM's primary use case is for telcos to deploy production workloads. The reality is that telcos are mandated to have significant high availability and fault tolerance schemes. A single point of failure is not acceptable in a telco deployment. Enter Kubernetes and OSM, both of them designed to have multiple replicas running, physically different nodes, provide greater system resiliency. Of course, the problem is we now have a distributed system, and there's a whole bunch of things that we need to consider when it comes to distributed systems. So what do I mean by a distributed system? This is a distributed system. There are two banks involved here. Or let's say OSM. There's two clouds, or maybe two tenants, two VIMs, or maybe a VIM and a Kubernetes cluster, or a PNF, a VNF, and a CNF. And there's many different systems that we're coordinating with, all in one transaction, if you will. Deploying a network service is talking to multiple distributed endpoints. This is one transaction. In this particular transaction, it's withdrawing a cash from one account and depositing into another. And what we know is we shouldn't lose money. This entire transaction needs to complete, or none of it needs to complete. So we start, as engineers, we go in, we say, you know what? The network might be a little bit flaky, so let's do some retries on the withdrawal. We start putting in retry logic in our code. We start, managing these sort of things. We don't want to fail immediately because we don't want angry customers going, hey, this is failing all the time. So we just put in a simple retry to prove it. But then, of course, we forgot. We also need to retry the deposit on the other side. And if either one of them fails, we now have to do what you call compensation to roll the entire transaction back, or at least get everything back into the state it was before we started moving money around. And this is the sort of thing that happens over and over again as we start building up reliable systems. Temporal was created to solve these challenges. Love the way they did this. They kind of said, oh, we call it a durable execution system. Okay, what's durable mean? Every execution is recorded to allow for recoverability, replayability, and correctness. What do I mean by that? What I mean is that Temporal takes care of making sure that a function that we said is necessary for completing a transaction or a workflow, that function is going to execute to completion. And if that function doesn't, it is then going to turn around and replay and say, well, we got to do that again. It guarantees a successful and correct execution of the function or service in the face of infrastructure failure. What that means is if LCM crashes in the middle of doing something, and we have Temporal managing our execution workflows, it's going to ensure that, you know what, that task isn't executing anymore. We got to reschedule it, restart it, move on. And it's a system in that they provide the sort of programming paradigm, architecture, and layout, abstracts us away from having to deal with retries and figuring out where they should execute and that sort of thing. So it allows us to concentrate on our business logic while they take care of the hard parts of figuring out retries, reschedule, where things should be scheduled, what processes execute, et cetera, et cetera. So operations in OSM, current state. OSM does have task management. Absolutely. There's a scheduler in the LCM, and I'm picking on the LCM right now, but there's also a scheduler in the RO. RO also has tasks and a bit of a task queue that it works with. So this works well, and it's gotten us to this point, and it makes for a nice logical separation of things. And we have these tasks that have life cycles, and we can query to see, okay, is it done yet? Where it doesn't work so well is if I bring up a second replica of the LCM or a third. Doesn't matter if it's co-located on the same physical node or in different nodes or however we want to slice it. The second OSM replica doesn't have code to say to the first one, hey, I'm taking this task, you take that task, and now we can start doing things, across systems. So the LCM is kind of, has a bit of work to do to harden this part here. And it's not something we're ignoring, and we're not saying it's good enough or anything like that. We just recognize that there is an opportunity for improvement here. So what exactly is a workflow that I'm talking about here? We talked, I mentioned workflows, I mentioned tasks, I mentioned LCM operations. All of this is a relatively nebulous concept, but we can define it as a workflow is something that has a start and an end, and hopefully gives us some type of meaningful result. So when it ends, we should be able to know what the status of it was, if there's data, use it in a follow-on workflow, etc. Workflows are a series of activities that are done in order to accomplish a task. For example, if I take deploy a network service, I can go through the LCM and come up with a high-level series of, just by looking at the code, we're going to update the NSR, the network service record, to say, okay, we're creating the resources associated with this record. We're going to update the network service state to building so that if anyone queries the network service, we can see we're working on it. Then we go into a section where we deploy any Kubernetes pods that need to be done. We get a public key from our VCA, so that way when we deploy VMs, we can give that key to them to manage them if needed. And we deploy execution environments. Lastly, at the end, we update our network service state or whatever. We've got our result. But this is good enough to say deploying a network service is an LCM operation. It's a series of tasks. It is a workflow. Just throwing another term, because that's the term that Temporal uses, but that's the basic concept. We've just got yet another term. It's a workflow. Okay, this works well for expected failures. Like, say, for example, there's an error getting the public key. Maybe even this is a VCA that is distributed somewhere and there was a network error with it. That's fine. Whatever the error is, our logic in our workflow currently in the LCM task is good, and it's going to say, okay, I know I've got a problem here. We're just going to go ahead, shortcut it, jump to the end, give our results, say that there was a failure building the network service. Great. Works well when we know and have code to handle it. What doesn't work so well is an unexpected failure. We're in the middle of getting the VCA public key and it crashed, or we lost the network. Now, OSM doesn't know what the result of getting the public key is. And it doesn't really have any code to say, I need to restart this, and I can skip, deploying KDUs because I made it to the VCA part and I can take over from there. Right now, what'll happen is this is just going to be left in the state that it was, and the network service will never finish deploying, or variants thereof. So, exploring a concept. What if I say that LCM operation is a workflow? Well, okay, that makes sense. These things are tasks. So when we looked at Temporal, they said it's best to do an incremental approach. Learning to use Temporal is done incrementally. You don't have to learn everything at once. They've got like a little 2 to 4 hour sort of exploring things. Let's take a look at some samples. Let's do some hello world, learn it, look at the SDKs, and then, do a little bit of play around, a little bit of refactoring or whatnot. And oh, by the way, we already have clients for your SDK, and we've got a server that you can use. So you don't even necessarily need to deploy Temporal. You can actually use their cloud offering, or there's a Docker Compose or a Helm chart, or Canonical themselves is also creating charms for Temporal. So there's great. The installation and configuration of the server is relatively easy. We have it up and running. So we did our little bit of learning. We grabbed their samples, took a look at the SDK. Here's a bunch of samples that they have that show a bunch of things that can be done. Basically restarting a workflow, child workflows, executing workflows once a minute, etc. So what did we do? We decided to write. Here is a typical OSM installation. Kubernetes, bunch of services representing the OSM services. We got our RO, et cetera, et cetera. Then we decided, okay, seeing as Temporal ships as a Docker container, an OCI, we can just go ahead and put that in the same Kubernetes namespace, and any of our services that want to talk to Temporal can. So we can have the NBI be a client. So that way, when something happens like deploy a network service, we can have the NBI say, okay, I'd like to start a workflow for deploying the service. Then we created what I'm calling right now our NG-LCM. This is probably not the direction we're going, but for the sake of just reusing some of our infrastructure and whatnot, we just said we'll create an NG-LCM Docker container based off of the LCM code base, but with a different main. And that main being connect to Temporal. And that says, at that point, we can put code for workflows and activities in our LCM. And then we turn around when we start up and we tell Temporal, hey, by the way, I've got the workflow code to be able to execute workflow A, B, and C, and I've got code to implement activities 1, 2, and 3. Interesting thing to note here when I say this container has the code for activities 1, 2, and 3. By the way, RO, or whatever, if we proceed with this, RO could have the code for some activities. So deploying a network service as a workflow now can be one end-to-end thing with an activity that executes in the LCM and another activity that executes in the RO, and Temporal will take care of the organization and the workflow and whatnot, and managing what code runs where. All we have to do is say, oh, the code for talking to OpenStack is here. That's an activity. I've published it. Come talk to me. So what I'd like to do now with that bit of background is turn things over to Gulsim.
Thank you, Mark. Now I'm going to make a demonstration which explain how we can use the temporal workflows to perform some tasks, such as periodic gridfs cleanup. Why we select this FsClean workflow? I will provide some background here. There was one existing production issue. The bug is raised with ID 2024. Basically, the problem is NSD and VNFD uploads can abandon some files in the database. Those could be charts or bundles, anything. And performance of file synchronization could be affected. This is the reason that we decided to create a script to, first we create a script to delete the files in GridFS. Then now we are implementing a workflow to show how we can make the same operation using the temporal. This workflow could be scheduled to run periodically, so it can always keeps the OSM file system clean. This is what we are demonstrating, and here is the abstract overview of the demo. Let's say we have one NGLCM mark already give the name, so I used the name. The NGLCM container includes the definitions of workflows and activities. In this demo, we are going to use two workflows. One is the FS upload workflow, and another is FsClean workflow. The workflows run some activities, and each workflow has only one activity. Then we need a worker. To execute a workflow, first we need a worker. The worker runs in the LCM container. So our first step is running a worker. This is the first step in the demo. To run a worker, we need a client to connect to Temporal server. The connection is set up by the gRPC. And as a second task, we need to upload some unnecessary files in our MongoDB GridFS. So we will execute the workflow, actually several workflows. Each workflow will upload only one file, and we will use a script for this. And this is our second step. And the third step, we will execute another workflow, FsClean workflow, to clean all these unnecessary files. We will use the Temporal UI to create a scheduled job for this. And this is another option instead of using the client to trigger the workflow.
The reason why Gulsim has created this, upload workflow to put orphan files in our database is because the bug was fixed. So we don't know of an easy way of creating garbage in the database. So we're explicitly doing that as part of this demo. So we wouldn't normally, create a workflow to corrupt databases. That's just a demo.
Yeah, thank you, Mark. The bug is fixed already. So this is how we can demonstrate to insert some unnecessary files. Yeah, this is the demo flow. Give a bit more details. We have the LCM container, and LCM container says, I already have the definitions of workflows and activities. So what we said, we would like to run a worker as a first step. To run a worker, we need some inputs to the worker. We need to provide the workflow names and activity names, which should be executed in the workflows. And we need to provide the test queue and the Temporal API. Actually, this is the information of the Temporal server, the IP address or DNS name, which Temporal server we would like to use. Those are the inputs, and we are triggering to run the worker. Then a request goes to Temporal client and the Temporal server. Temporals, when we reach to Temporal server, the worker will be registered, and the Temporal server says, I'm aware of this LCM worker, and I can manage this worker after that. Okay, the first step is completed. Now we would like to execute our FS upload workflow, and for this reason, we are using an external script here. Let's say this is an external client, or this could be the MBI or another container, another OSM container module. To execute a workflow, we need to provide some inputs, and we need to provide the workflow name, some arguments to workflow, input arguments to workflow, a workflow ID, and the test queue. This test queue is important because the test queue should match with a worker. Otherwise, this cannot be executed. No available workers could be found. The request goes to the temporal client, and client passes to temporal server. Temporal server looks for an available LCM worker and finds it, and the task is executed. Finally, the results return to the client again. This is our flow, and let's switch to our demo. We said we first need to run the worker. When we run the NGLCM module, it will run a worker. We set up the method to run this in the initial step. Let's start the NGLCM container. And in the log, we see the queue here, worker created with the test queue, LCM queue. Now a worker is running in our LCM container. Now let's go to second step. We would like to execute FS upload workflow in order to upload several unnecessary files. This is a small script, just takes the temporal server IP address and number of files to upload. Those are the dummy files. They have some unique IDs, but those are totally dummy files. We are going to execute this script with 200 files, and let's do this. Now, we saw in the log the workflow FS upload started, completed, and each workflow added one file. This is the ID of the file. So the workflow we run 200 times in here, and 200 files will be uploaded. At the same time, let's switch back to LCM container logs. There are some activity logs here because these workflow run in the worker. The worker is running, executing this workflow. So the logs already gives the details. They are activity run, the file is added. So this is what we expect, or worker running at the moment. Let's switch to UI. This is the UI, and now we see several workflows are already completed, and we can check the details. FS upload workflow includes one activity, upload unnecessary file. This is the activity name, and this is the worker which is running at the moment, the ID of the worker. And in the details, we can see the result. This single execution, workflow execution, says one file is added with the file ID. Very quickly, we can see in here there are several events, starts with the workflow execution, and at the end, workflow execution completed, and there is also the result provided. So our script done its job. It uploaded several unnecessary files, and we can execute another workflow, FsClean workflow, using the temporal UI. We would like to show how to create schedules. Let's create a schedule with a name cleaner, and we need to provide a workflow type. Workflow type should be equal to the workflow name, exact workflow name, and workflow ID could be something ID, which is a dummy name in here, and test queue should match with the worker test queue. This is already logged in the LCM container, which is LCM queue. And we need to provide an interval. Let's say this workflow runs every 30 seconds. And we are creating the schedule. Now cleaner is running. We can see upcoming runs in each 30 seconds. It didn't run yet. We can go to workflows and let's check. Now it is running. It started to run. We can switch back to container logs. Yes. Now the clean FS workflow executed and single activity run, and now it logs all the IDs of deleted files. And at the end, it should return a result, how many files deleted. Yeah, it's flowing a bit slowly. While we are waiting, just check the FsClean workflow here, what it did exactly. This is the result from activity. The first execution says deleted file counts. 200 files are deleted. This is what we expect because we uploaded 200 files. And then the other periodic executions gives the result. There isn't any deleted files. So this is expected also. It keeps running every 30 seconds. And the activity result is also logged in here, and the other activities also logged in here. We performed our 2 different workflow execution, and we got the result from those workflow executions. And we can say these workflows could be used to perform any task, even using with schedules, or we can provide several parameters if we want. So do you have any questions?
So in case if we start using Temporal, so does it mean we will not be using Kafka?
That's a decision that we haven't necessarily made yet. Certainly, we can do things like reception of a Kafka event over on the LCM side could trigger the workflow. But then what we're kind of doing is we're binding logic to receive that event to a specific LCM. So I know that the Kafka bus is used externally. People like listening to our Kafka event messages. So there's nothing stopping us from having an activity in any one of our workflows be an actual produce a Kafka message. We're in early exploration stages here. We're looking at things like what sort of code do we need in order to make sure that something consumes the Kafka message and that it's going to be executed on to completion, and that it's executed, that each step is executed only once. We need to, we've got a little bit of that code in OSM, but perhaps it's time to turn that flow around and go, we want to use Kafka as an external messaging tool the way we have right now, so that people can subscribe to that as a notification event, but not necessarily to continue driving our application logic forward, because we recognize some of the shortcomings in Kafka. Decision that hasn't been made yet.
Okay, but yeah, this looks very interesting. Thanks for this information, Mark and Gulsim.
Yeah, thank you so much. Any other question?
I'm going to point out there's one other little interesting thing. Gulsim, could you just go back to the Temporal web UI for a second, just as a simple thing? Okay, so you'll notice in here on any particular workflow that is executing, you can see we got a start and end time. So we know how long a workflow takes to execute. If you go into a workflow, each activity has a start and end time. So we now have a profiler that tells us how long this activity took to complete. So free of charge, we now have a little bit of instrumentation for our code, where we can start looking at things like what takes a long time. Are there things that we can do to improve our performance? Like, are we waiting for something that could potentially be done in parallel? So these are the nice type of little free to have things that come with Temporal. So not only does it, does it help us not have to worry about scheduling of things and where things are going to be executed, and in the event of a crash, restarting them, but we also get a little bit of profiling out of it. And this can be used to replay a series of events for debugging. So we do need to be careful in OSM about the data that goes in and out of a workflow, because that is serialized to the central server and back. So there are strategies. Let's say there was confidential information about a particular tenant in there, and we don't want that recorded. We can certainly do things like have lookup tables such that the data is never in Temporal, or if somebody decides that they wanted to use Temporal Cloud. I know that there have been some telcos in financial sectors that have used Temporal, and they have extreme data sensitivity challenges, and they have come up with ways of addressing that. So yes, you can see parameters here. It's a good thing for developers and debuggers, but it's also can be obfuscated and levels of indirection introduced if we're concerned about that. And I think I've taken us over time, so I shall stop now.